I am Shubham Godambe, a third year undergraduate student pursuing my bachelor's in information technology at Siangad College of Engineering, Pune. Here I am a team representative of our team, CODEMANTRA. Now I would like to introduce my team with you.
Hello, I am Gaurav Singh Best from SCOE third year IT.
Hello, my name is Siddhant Deshmukh. I am from third year IT department.
Hello, this is Akshay Brahmankar from third year IT at SCOE.
Hello, I am Sonakshi Singh and I am third year IT student from SCOE.
Hello, my name is Tanvin Arkade. I am third year IT student from SCOE.
So now I would like to give you our problem statement code and our problem statement title. So our problem statement code is SIH-1316 and our problem statement title is Application of Image Analytics for Tree Enumeration for Diversion of a Forest Land. So from here, I would like to hand over the conversation to Sonakshi to initiate the further solution for our statement.
Before moving forward, let me give you insight about our problem background. So when forest land is required for development, it's really essential to understand the tree population within that area accurately. But the problem with traditional methods like manual surveys was that it was too time consuming, costly, and it was definitely prone to errors. This problem raises the need for an accurate and efficient method to count the trees in forested areas when the forest land is being diverted for development projects. To address these challenges, we are developing an image analytic solution that will automate the tree counting process using various types of imagery like satellites and drone images. And to explain more about our problem solution, I'll hand over the PPT to Gaurav.
So hello again guys. Now I will explain you to the methodology of our solution. First we will start by the collection of data which will be by different methods like GIS data, ground data and UAV data. Then after collection of data, we will send one raw image copy for density calculation, which will be tree density calculation, and another part for image processing. And this processed image will be used for different purposes like tree counting and tree categorization. For tree categorization, we will be using different parameters like species in a particular area and tree crown diameter and other parameters like tree leaves, which are quite obvious. And after calculation of tree count, tree categorization and density calculation, we will be making a viable decision for deforestation and development on the land. Now I will be explaining you the features of our solution. The first feature will be tree counting. Using map coordinates and aerial images, we will be doing tree enumeration process. And next will be species identification. Using the same aerial images and drone analysis imageries, we will be doing species identification and species density calculation. Basically, this species identification will be done on the basis of various parameters of species like tree crown diameter and local available data on the trees in the specific area and other more parameters. Then we will validate the results with the ground truth data collected by the agency. Then we will be doing land analysis. In this, we will basically tell if the land is viable for deforestation or development. Then we will also give visualized result in the form of graphs and charts and tables, which will enable user for easily deciphering the results. And then we will also give weather updates, which will enable user for more further uses. Now I will hand over the presentation to Sonakshi Singh for use case and dependency.
Now I'll tell about the use cases. So first is government agencies like forest, land management, and Ministry of Coal. They require accurate data for land diversion decisions. Next are environmental consultants. They need precise information for environmental impact assessment during land diversion projects. Next, we have real estate developers. So, companies which are involved in land development projects, they can benefit from the data-driven insights provided. Next, we have conservation organizations. So, organizations which are focused on preserving natural resources can use our project to monitor and protect forests. Next is our dependencies. So, first dependency is forest management database. Next, we require updated and high resolution satellite image or drone images for accurate prediction. We require reliable ground truth data for model training and validation. And we require a cloud platform to store our data. Next, I will hand over the presentation to Shubham.
So here you can see that we have created a small prototype for our application. On the home screen, we have written our problem statement, that is application of image analytics for tree enumeration for diversion of a forest land. In the bottom bar, we have given a small button. By clicking on this button, we get two sections. The first section is for satellite and the second is for the gallery. In the satellite section, we are going to implement a map version. Means in that map, we are going to depict a point and we can choose a particular area by its coordinates. And on the basis of that coordinates, we are going to predict our result. And the second section is about a gallery. So in the gallery section, we are going to browse the image from our gallery and we can choose any image, whatever we want. So I will choose this image. So next, and after clicking on the result button, here you can see that we get a result of four types. The first result which we get is tree count. So in this image, you can see that every tree is encircled by a green circle. That is means every circle represents a tree, and we can get a total count of trees by just a satellite sensing. Second result which we got is the species detection. So as of now, we have not implemented the whole model for species detection, but it is under progress. So basically, I will give you the idea of what we are going to do in the species detection. So in this species detection part, we are going to predict the approximate density of various type of trees in the given area. So the third result which we are seeing on the result screen is weather condition. So in the weather condition, we are going to get a result of a real-time weather condition for further use if any related works we have to do. And the last result which we see on our result screen is the development condition. In the development condition, we get two sections. The first one is the effect on environment, and the second one is development condition, means the land is suitable for the further construction projects or not. So in the effect on the environment, we are gonna implement a model which will show us the if we get the cut the trees in the particular area, what it will affect in future on that given area. And the second section is development condition. Here we are showing in the form of pie chart that the given land is suitable for construction purpose or not. Is that if the trees in the given area are important, then it will show a red alert, and if the trees in the given area are much dense and are not much important, and if the development is required, so it will show in the green chart that the given land is suitable for development and you can do the further construction on the given area.
Now, I would like to highlight few features of our project. So, the proposed solution can be used on any platform, whether it be Android, iOS, or website. We will be integrating it with already existing platforms for making their task easier, and we will be using cloud platform to store data. Now, in conclusion, I'd like to add that it can be used by a varied range of users like Forest Department, Ministry of Coal, real estate developers, and many others. This will enable them to avoid manual laborious task of tree enumeration on large scale and will help in decision making of forest land diversion for development purposes. Thank you.